A very good afternoon to all, and welcome to session 3 of day 2 of the FDP on emerging trends in sustainable technology, sponsored by All India Committee of Technical Education, New Delhi, and organized by MITE Institute of Technology Engineering, Moodabidri. I am Dr. Vignesh Nayak Ullal, and I am the coordinator of this session. So, as a reminder, participants are requested to kindly mute their audio while the session speaker delivers his talk. It is a great privilege for me to introduce our today's distinguished speaker of this session, Professor Kumar GN, who will be sharing his knowledge on the topic of sustainable energy integration in smart cities. So, for the benefit of the participants, I would like to go through a brief CV of Professor Kumar GN. Professor Kumar is an associate professor in the Department of Mechanical Engineering at NITK Suratkal. His areas of research include alternative fuels for internal combustion engines, simulation of IC engines, and heat transfer. Professor Kumar had earned his PhD in the year of 2011, and his specialization was on development and performance evaluation of a hydrogen fuel spark ignition engine for vehicular application. Professor Kumar is also an alumnus of NITK Suratkal and had done his master's in the area of heat power engineering at KREC Suratkal. Professor Kumar also has applied for a patent and has 36 research publications to his name and has worked widely in the field of thermal engineering and mainly on emissions in compression ignition engine as well as volumetric gas flow rates in spark ignition engine. Professor Kumar has also attended 31 international conferences, especially in countries such as Japan and Korea. He has also uh, attended national conferences in various NITs and IITs. Professor Kumar GN has also co-authored textbooks, reference books, and book chapters on thermal engineering. He has also guided 4 PhD scholars and and is presently guiding 5 research scholars in their PhD endeavor. Professor Kumar also holds membership in IST as well as in Combustion Institute. He is also serving as a BOE member at UVC Bangalore and is a co-chair and was a co-chair during National System Conference 2010 at NITK Suratkal. He has also delivered a number of lectures at various colleges in India. So, with that brief introduction, I welcome Professor Kumar Jian to this FDP program and kindly request him to deliver his talk. Over to you, sir.
Yeah, thank you, Dr. Vignesh Nayak. I thought my student, his name is also Vignesh Nayak. He is working as a STEM professor in AJIT, that is AJ Institute of Technology. So, yeah, it's nice meeting you. So, I welcome to all the participants and good afternoon, one and all. Anyway, the mic is mute, so I know it is a. I mean, you cannot respond. Uh, so today, I think two sessions already you attended, and you have understood about the smart cities. Because nowadays, I mean, the government of India as well as state governments or the local politicians, they speak about the smart cities or the development of the smart cities or what are planning for the future. Also, they are highlighting, and every day or I mean, weekly we are seeing some updates regarding the smart cities. And the government of India has identified some cities, already developed cities, and they wanted to convert smart cities. So, I mean, maybe from two sessions you already understood the what is smart city. Okay, so I'm not talking about the smart cities. I'm talking about the energy which are required for the smart cities, and what are the steps to be taken in this regard. Okay, so if you have any queries, maybe at the end of the presentation, you can ask me. But I'm not that much expert. Whatever information I collected from the literature, I'm highlighting in front of you. Okay. Just a minute. Can you see the slides?
No, sir, not yet.
Sorry. Now, can you see this? Dr. Vignesh, can you see my slides?
Yes, sir. Yes, sir. I can see,
Oh,
sir.
Okay,
okay.
sir.
What about other?
Yes, sir, it's
Yes, sir.
visible.
Yes.
Yes, sir, it's
It's visible.
Okay. Thank you. Thank you. So, as I said, I mean, energy is one part of in the smart cities development. So, just I'm going to highlight. So, in the presentation, I'm going to cover these things: the introduction, which includes sustainable energy and integration with the smart cities. That is why we are going for sustainable energy and in the smart cities. I'll highlight a few points on this. And with respect to the sustainable energy, we have to assess, that is, we have to analyze, and based on the problems where I'm going to highlight in the second point. Third, why do we need sustainable energy? Because I mean already energy is there, current, and the current is generated or the electricity is generated from different source. Already we are familiar, but what is sustainable energy for the smart city is very important thing. Just I'm going to highlight these things. What do we need to do so to introduce sustainable energy, or for after analyzing the sustainable energy, so what we have to do as a local man, as a municipal corporation, or the state government, or the central government, what they have to do. And finally, the energy integration method for sustainability. Different energies are connected, or we can identify to make sustainable energy for the smart cities. So you may be knowing, maybe some 4 5 years back, the government of India introduced the world smart cities, but it's not new to the world. Is earlier, I mean, it is existing, but it was existing everywhere. But in India, it has given some name just to develop the uh, or to improve the existing cities into international quality or international standard cities. So, keeping in this mind, the government of India has taken action, and they've identified the stakeholders, and then the work already be- began, because they have identified some cities, and the government of India is investing some money and the ideas. So the work is already started. You can observe in Mangalore, as well as some many cities like Davangere, Mysore, and etc. So why we have to go for smart cities? I think from 2 sessions already we have understood. But my point I'm going to present in front of you. So you are aware of this population increasing, or everywhere. That is whether you take Asian countries, or European countries, America. Everywhere the population is increasing day by day, and the we are reaching maybe 900 crore by 2040. So at presently we are 6 billion, that is 600 crore, that is a world population, and India 136 crores presently, and we are moving towards the top position. Maybe 2050 we will be at the top position. When population is increasing, so the people are moving from a rural area to the urban area, maybe in search of jobs, or maybe job, for livelihood. For when they shift from rural area to the urban area, the other things also will start. We have to make housing, transportation, the food, water, electricity, and etc. But when population increases, the other things are also very important thing, including the energy, because whether you take water supply, otherwise transportation, everything is depending on the energy. Okay, so when population increases, the energy consumption also increases. So, if you take world population, more than 75% of the people are located in Asian continent and Africa. And you can see the slide. And because the India 136, maybe China 150 plus crores. So all put together, it is coming around nearly 3 billion. Okay, so 300 crore. So there is more population located in Asia and Africa compared to other continent. So because of this, we may consume. We are consuming more energy. But only thing is, we have to see the energy production also. or energy production from which source? Because we are mainly depending on the fossil fuels for the transportation, and for the electricity generation, maybe nearly we are depending on the coal, and some percentage coming from the hydraulic and nuclear energy, and very few percentage from the renewable energy. Okay, so we have to uh, introduce, or we have to identify the energy. It should be locally available, and it should be clean, and it should sustain. I mean, it should come for a long time. So, like, I mean, we have to identify such energies so that we can avoid importing of fossil fuels, or we can improve the GDP or economy of the country. So with respect to the world consumption, world energy consumption by sector, that is four important sectors are there, including industry, transportation, residential, and commercial. So industry, you can observe 51.7%. So including automobile industry and allied other industries coming in this. So transportation, already you are familiar. So because when the global is by maybe by air or by water, by road. So we are using transportation extensively. When we start using transportation extensively, again we are depending on the fossil fuels, or some percentage is taken from maybe biodiesel and other local fuels. And next comes the residual energy consumption. So you can observe that nearly 14% of the energy goes for residual purpose, and some nearly 7.8% of energy is consumed by the commercial for other shopping and road and etc. lighting purpose. Okay. So it is the same similar information, but when we move from year to year, so you can observe the energy consumption with respect to industrial purpose, or transportation, or residential or commercial purpose. The energy consumption or energy demand is increasing. So when energy demand increases, we have to produce energy, or we have to convert energy from one source to the another source. So this is generally I talk related to the alternative fuel, and my main work was on alternative fuels. So I always look for the transportation aspects. So you can see the Asia Pacific, the heavy duty transportation. Okay, so, fossil fuels required. Uh, so compared to other countries, the continent. So Asia Pacific fuel consumption is more because of more population, and it will be doubled maybe after 20 years. So we have to see, we have to see this point, and we have to work towards the alternative energy. So with respect to the transportation energy demand by sector, so including the road transportation, heavy duty transportation, aviation, and marine and rail. So but within 20 years, the energy consumption will increase. The same pattern you can observe for other sector also, like industry, residential, or commercial purpose. It is increasing day by day or year to year. Okay? And this is depending upon the region. So how the energy consumption will increase within 2020 to 2040. We just you can have a look. I'll skip. and maybe the oil prices it's not it is an old one, but today it is fluctuating. But I mean, the trend will be same. It's not constant. Every day fuel prices are fluctuating, maybe 30 40 dollars per barrel to 70 80 or 100. So every day is fluctuating. So when we cannot fix the oil price, and it is controlled by OEM, okay, OECD. So with respect to transportation, so as I said, when population increases, the transportation also increases. So maybe heavy duty transportation demand grows 60% by 2040. That is within uh, I mean, maybe it's compared 2010 to 2040. That is within 30 years, 60% heavy duty transportation will increase, or the vehicle will increase. When vehicle increases, so the emission also increases. So you can observe. So maybe, I mean, I think most of them you are aware that in India we are planning to introduce, I mean, already introduced Bharat Stage 6 vehicles, that is emission norms, so that the carbon dioxide is uh, reduced. But that is based on the 2015 Paris Agreement. That is, world leaders have met, and they have taken a decision to reduce the carbon dioxide by 2040. Otherwise, it will affect on the global warming. Maybe the temperature will rise, and it will affect on the other uh, maybe plants, or including humans. Okay. So now you can see the energy consumption. I mean, when we use fossil fuels, or including coal, so the carbon emission releases. Okay, in terms of, I mean, with respect to the uh, region wise. So other countries are this much, and China, India, you can observe. So we are planning to reduce the carbon dioxide by 2040, but at presently we are here at the peak condition. So the government of India already had taken steps to reduce the carbon dioxide. One is I mean, as I said, emission norms are introduced for automobile sector, as well as industries, including thermal power plants. So now instead of thermal power plant, that is I mean, thermal power plant based on the coal, they are planning to switch over to the non-renewable energy. I mean, renewable energy sources like solar or wind energy. Okay, so this is same information. Uh, I mean, that is with respect to the per capita, and this is with respect to GDP. Yeah. So now I'll take up the sustainable energy integration to smart cities. So we have observed when population increases, and the human generally look for the comfort life. Okay, comfort life means maybe less traveling, or easy traveling, and the standard of living, or living standards, should be easy. For example, if I buy something without any hustle, it should come to my place. Okay, sitting at one place already, online purchasing, that is one of the easy way of purchasing, and now it is getting popularity in that. So that is where people are looking for more comfort. So not only with respect to the uh, business, so the other things like the energy, that is transportation, water, uh, other things, including business, it should be some standards without any problem. So with respect to this, the smart cities or developed or planned. So what is smart city? Already we have understood the smart city is nothing but maybe when as per the this one just, as per the definition of a European country, a city seeking to address public issues via ICT, Internet and Communication Technology, based solution on the basis of a multi-stakeholder. That is, a multi-stakeholder is nothing but the government or the governing body, including the private part, the investor and the local people, including the local administration, should involve and uh, make the city which can give comfortable to the uh, people. That is, a city seeking to address public issues via ICT-based solution on the basis of a multi-stakeholder, municipality-based partnership. These solutions are developed and refined through smart initiatives. Okay, so that is, smart city should give comfort to the human. Okay, by proposing or by implementing the standard procedures, standard transportation, the supplies of water or electricity and etc. Okay. So keeping in this mind, so the energy, that is a sustainable energy is a must, or sustainable energy management is must. Otherwise, the other things like maybe industry or the business will collapse if the energy is not maintained properly. So the energy is a very important thing. That is maybe in terms of electricity or in terms of fuel. Okay, so that is energy should be required, and it should be long-lasting energy. And energy sources should not last. And the next stage is coupled with IoT. Whatever, including, for example, you take controlling of traffic. So we can use Internet of IoT, that Internet of Things. So the Internet and communication we have to use extensively for the operation of the traffic, or including the data collection. For example, now if I want to take the my other card sitting at home, I can able to take. That is, I should not go to some office, stand in the queue, submit all the documents. Those things will be avoided once we implement the smart city. Okay. And the why smart cities already I highlighted from the previous slide, because of population, because of energy demand, because the next rapidly growing uh, sorry rapidly growing footprint. That is, when we use fossil fuels or any hydrocarbon fuel, the carbon dioxide will be released. So how to control this carbon dioxide is also one question. Okay, so you can observe the picture, including smart city included industry, security, retail, that is business, society, healthcare, home, energy, mobility. So everything is included in the smart city. So we cannot see only the city planning, that is the construction of the building. It's not so. Once you construct a house, we have to see that minimum energy consumption. That is, we have to depend on the natural light. We have to depend on the natural air. So we should not use. We have to minimize the usage of air conditioning system or lighting system. Or when we use the lighting system, instead of CFL or the bulb system, we have to go for LED lights, so that we can consume the, we can reduce or we can save energy. Okay, and even healthcare is also very important thing nowadays. So since from 6 months you have seen Healthcare is also very important thing, and India is lagging behind in this sector. So we have to identify, or we have to rearrange the health sector properly. So including the security, that is maybe with respect to the police or other security system, we have to improve. So when smart city is designed, so all the sectors are included in this. So beginning, I told when India, I mean, government of India has proposed this idea, so the work is started. But mainly people are talking about the sanitation or transportation, that is a road building or changing the shape of the buildings, okay, or municipal finance and water and etc. But nobody is talking about the energy or the source of energy, because whether you take electricity or the fuel, I mean fuel for the transportation, because already we have seen maybe 27% of the energy goes for transportation. So we have to see that uh, sustainable energy or the energy we should not import from the other countries. Otherwise, our GDP or the economy will fluctuate. So the assessment of energy. So we have seen the introduction, and we have seen the importance of energy with respect to the smart city. Now we can analyze the sustainable energy for the smart city. So when we analyze, that is, for example, if 10 lakh people are there, how much electricity is required, how they are consuming, and what are the transportation, whether unnecessarily energy consumption or transportation, energy lost by transportation, we have to see. Because now you are seeing most of them are using private vehicles, that is personal vehicles. So for one person, one car, so maybe fuel consumption will increase day by day. Instead of taking a personal vehicle, we can go for public transportation. Maybe instead of bus, even we can go for metro rails, metro. So when we introduce metro, definitely the energy consumption will reduce. So whatever energy consumption is happening, so we have to collect the data, we have to analyze how to improve efficiency of the heat system we can do. The transportation energy, mobility, already I told you. Next, the building model solution and environment. As I said, the building should be constructed. Uh, we have to use natural light, natural air circulation, so that we can reduce the consumption of electricity. With respect to the second point, that is transportation, energy, and mobility. And nowadays, we are planning to uh, introduce battery operated vehicles, and by introducing battery operated vehicles, we can reduce the carbon dioxide emission in the urban area, not in the where we are producing the electricity. So that, that is one solution. Second solution, we are planning to use hydrogen fuel also. That is a clean fuel. And recently, the government of India is identified the hydrogen as a auto fuel, and they've introduced safety codes also. Maybe, including many automobile manufacturers, they are working towards hydrogen fueled based vehicles, maybe in IC engine or in fuel cell. Maybe in future, fossil fuels dependency will be reduced, and we are moving towards the hydrogen and hydrogen based IC engine or hydrogen based fuel cell. Okay, so that is a clean energy. Next, building models, as I said, we have to use the uh, building material in proper way. So I think many of you are maybe knowing the whatever ash is created in the thermal power plant it is converted into bricks, and the people have started using for the construction. We have to see that wherever material is required for a building, uh, we have to, without the destruction, we have to use user-centric consideration. So, as I said, we have to relocate the schools, colleges, healthcare center, office, and etc., so that people can access without much transportation. And we have to go for IoT system, that is internet-based activities, so that you know. And this is the one of the example. Earlier, for giving a 1 hour talk, I used to travel 1 or 2 days. That is one day we have to travel just 1.5 hour invited talk, then again maybe 8 to 10 hours traveling back. So maybe one way is good, but only thing is we are missing the feelings. Okay, maybe we have to adjust and we have to go ahead with this. Whatever information is available online, so we have to extract the best thing and we have to go ahead. So next is a system integration. Looking there is a, with respect to the sustainable energy, so we have to see the locally available energy sources. So for example, you take the biodiesel, assuming that the wasteland is there, we can grow the jatropha seeds and we can convert jatropha into oil, that is biodiesel, and that can be used in the existing IC engine. Or we can go for this one, hydrogen. Or next, maybe we can say, for example, next slide I'm going to highlight about the solar energy. Some places it is not, some land is not useful for cultivation, and such lands can be used for solar energy extraction. Okay, so for example, in Karnataka, Pavagada, district, that is Madhugiri district. So uh, solar energy is available at higher quality. So now they've installed the PVC panels, photovoltaic panels, and they're extracting maximum electricity from there, from the solar. So we have to identify the local fuel, so that we can reduce the importing of fossil fuel. That is one. And we have to make sustainable. We have to see that it should remains constant. For long time. Next, including the source with existing technology. So already we have told. See, for example, the coal is available in India, but it is not that good quality coal. So nearly 45 to 50% ash content will be there, and the carbon content is very less. How to improve or how to convert this existing coal to other form of energy? Maybe we can convert into syngas, and or hydrogen, or some water gas, or this one we can convert and we can keep it ready for the energy, for the utilization. Okay, that is a source of energy is also very important thing. Further, migrating to the probable carbon free sustainable source, as we already pointed out, we have to switch over from hydrocarbon fuel to the uh, carbon free fuel, including hydrogen. Okay, that is a fuel cell, or the solar energy, wind energy, maybe sometimes even we can consider geothermal energy. But only thing is, when we adopt renewable energies, so it is a high investment is involved. So the government India should, government should come forward and invest the, or initial investment should do. Maybe the operating cost can be taken from the other consumers. So why do we need sustainable energy? Okay. So here, for example, already I pointed out some issues. So including coal, out of 269 billion tons of coal reserves, just 20 billion tons is extractable. The remaining is it's there in the earth and very difficult to extract, or the operating cost is very high. So that is one part, and the quality of that one is also not good. Okay, so bituminous coal. And oil, you can observe here, 894 thousand barrels per day production versus 3,729 thousand barrels per day consumptions. So you can see nearly 3,001, 2,900 thousand barrels per day we are importing. Okay, we are importing from the other countries, even Iran. Okay, so when we import the most of the, our economy is depending upon that, and including the dollar price is fluctuating day by day. Okay. That is one aspect. And the natural gas, you can see even the natural gas is available in northeast states, including Gujarat Basin, Orissa. So we are extracting natural gas, but we require this much. Okay, so again, when now it is increased more, so the natural gas consumption, because natural gas is are using in Delhi, Mumbai, that is most of the metropolitan cities, and so the consumption is also increasing day by day. Okay. The source of energy used are two under non-renewable: threat to energy security, that is a very important source. The source of energy is a very important thing, and outsourcing too leads to very critical measure of economic. As I said, once we start importing, if we invest more money on the importing the fossil fuel, so the whatever they say we have to do, that is maybe our economy will be slightly changing. Please. What do we need to do? So, yeah, just as a common man or as an administrator, you can see to invest in building effective renewable energy technologies. That is, when we take the smart cities, we have to identify the location or area where we can install the solar energy or wind energy or some renewable energies, so that we can easily transport. But there is transportation is also very important thing. I'm going to show you now. Because when we transport electricity or electric energy from the uh, source to the uh, consumption, that is of urban area, nearly 20 to 25% of energy will be lost through transmission. So when we use the renewable energy technologies, we have to see that minimum energy loss. So I think nowadays the solar panels are mounted on the tall buildings, including in our institute, that is NITK Suratkal. If you visit, just to go to main building, top of the building, you can observe solar panels, and most of the buildings, mean PV panels are installed, and the whatever energy is produced, electricity is produced, it is connected to the grid. It goes to the main supply, and again they are giving back to us maybe with a concessional rate. That is, we have to identify the renewable energy so that we can use the effect. We can use effectively. That is one aspect. The second one, as I said, when we are constructing a building, so we have to see that natural light or natural air should come. Okay, that is one aspect. And next thing is when with respect to the transportation, for example, maybe half kilometer or 1 kilometer, instead of taking scooter or car, we can go by cycle or by by walk. But the question will come whether it is a safe. But once we develop the smart cities, the roads will have that facility. That is, pedestrian, there will be separate path, cycle separate path, and maybe other vehicles will have separate road. Okay. So when we are planning for the smart cities, we have to see all this aspect. Yeah. Develop energy efficiency technologies. So you may be knowing the technologies, the new technologies are coming with higher efficiency devices, including, for example, you take a car, maybe 20 years back, or maybe 12 kilometer per liter, but today 20, 22 kilometer per liter. That is, efficiency is introduced, including the batteries. Earlier, maybe plate type. Now nowadays, tubular type of batteries are coming, and it is give more efficiency, and maintenance cost is less. So like this, there is a scope. Even ICE engine is not old. Even though it's old, there is a scope for improvement, because we are getting 35 to 40% efficiency, thermal efficiency, but remaining maybe 100, 60% we can convert into useful energy. Okay, that is the one. Right. Develop energy storage technologies, because for example, you take the solar energy or wind energy, the energy is produced, and we have to store, and we have to utilize whenever it is required. So that is a storage system is also a very important thing. Next, need for research, development, and deployment, RD and D. That is, a research, development, deployment is a very important thing. So whatever point out I told, even once we identify the renewable technologies, so we can improve the efficiency, or the energy storage system also we can introduce. In this aspect, we can do the research, we can improve the technology, and we can introduce to the common man. Okay. Energy integration method for sustainability. So I'm not giving you 100% information regarding this. Whatever was, it was available in the literature, just I made it into one presentation and presenting in front of you. So maybe, if you start searching for paper related to the carbon capture, you can find a lot of papers. In India, very few people are working related to this. So whatever carbon dioxide is produced from the transportation, or from the industry, or from the thermal power plants, so it can be captured, it can be transported to the place where we can store it. Okay, and we can use for the other purpose. Okay, so you can see capturing of carbon dioxide, transportation of carbon dioxide, storing, and underground in depleted oil and gas field, or deep saline aquifer formations. So whatever carbon dioxide is captured, we can send it back to the earth, or we can store it there, and that will be converted into maybe fossil fuels in later stage. But only thing is, when we bury in the earth, so again there will be drawback. Okay. So the benefits, you can see the carbon dioxide emissions entering into the atmosphere. So that is advantage. So we can, because we are capturing and we are sending or buried in the earth. Excellent health and safety record, because carbon dioxide in the atmosphere reduced, and global warming temperature can be reduced. Drawback including increases fuel requirement by 10 to 40%, because the carbon dioxide is produced from hydrocarbon fuels. And nowadays, as I said, in most of the metropolitan cities, for transportation, CNG gas is used. That is a compressed natural gas. It consists methane as a major constituent, and other constituents are very less. When we use methane, that is CH4, hydrocarbon ratio will increase compared to isooctane. And because of less carbon compared to isooctane fuel, that is petrol or diesel, the carbon dioxide emissions are less. Even compared to coal emission, the emissions, I mean, carbon emissions are less, carbon dioxide emissions are less in natural gas. That's why in Delhi, I mean, after introducing the CO2, that is maybe in 1991 or 92, so the carbon dioxide emissions are gradually decreased in Delhi. Okay. Convenience, because natural gas, and it is easy to transport, easy to store, and easy to transport from one place to another place, maybe through pipeline system or through cylinder system. It is convenient, and you can observe the facility in Delhi. Okay, so the gas is supplied from Gujarat to the Delhi or Mumbai. Yeah, in Mumbai also they are doing. Okay. Versatility and safety. That is, as I said, because of its property, it is safe, and it can be used uh, effectively and safely. Drawback: carbon emissions are still exist because it made up of carbon and hydrogen element. So carbon will be converted in carbon dioxide or carbon monoxide, and there will be leakage of gas even in when we are extracting natural gas. We cannot capture 100%. Some leakage will be there, or during transportation, or during filling of the gas, the leakage will be there. That is hydrocarbon. I mean, natural gas is escape, and it mixes with the surrounding air, and maybe carbon dioxide will increase. Maybe, I mean, these are all new technologies are proposing for the smart city, because we have to avoid importing of fossil fuels. Okay, underground coal gasification. So you can see the, I mean, the whatever coal is available, we have to convert into other form of energy, maybe hydrogen or syngas, carbon monoxide or H2 gas, and H2 can be used as a fuel, or we can use, I mean, we can convert coal into methane. Some technologies are available, but still at laboratory level, it has not come to the uh, uh, land, that is for the public. It's not used extensively. So the coal can be used effectively, and it is a, that is a gasification, that is underground coal gasification can be done. Whatever emissions are coming, it is buried inside the earth itself. So the advantage: positive social and environmental impact, because there is no carbon dioxide release, because it is trapped inside the earth. So that is the one advantage. Challenge: the technology. Okay, we have to see that the whatever technology existing, we have to improve so that it gives the maximum this one. The disadvantages you can see here. Uh, when we identify the underground coal gasification site, again that area, water ground contamination will be there, carbon dioxide emission contamination will be there, and the surface also, the quality of the earth, I mean, earth surface will also deteriorate. So volatilization of mercury, because of adding carbon dioxide, or due to temperature. So volatilization of mercury will happen. Again, it's a problem. Arsenic and selenium chemicals are volatile, volatile because of property of the these chemicals. So next, as I said, we have to give importance to the renewable energy, instead of depending on the fossil fuel. So with respect to this, the wind energy and the solar energy are more useful energies because I mean solar energy, and already Rajasthan and UP, including Karnataka, they've installed solar park. Okay. With respect to the wind energy, even if you visit Chitradurga district or in Tamil Nadu, Nagarkoil, you can observe how this wind energy is effectively used. But only thing is, if wind energy is available extensively, I mean that is a permanent. But only thing is, we have to extract that. I mean, we have to convert wind energy into electricity, and we have to supply. We have to see that the transmission losses should be minimum. Okay. So with respect to India, the wind energy you can observe around 37,000 or 38,000 megawatt power plants are installed. That is, the wind power plants are installed, and annually 2 gigawatts is getting installed since from that is day by day they are installing new wind energy power plants so that the consumption, I mean, production will be improved. So these are the information I've taken from the and maybe the government of India, I mean, introduce some methods, that is Make in India concept or Skill India, Skill India. So when we utilize this facility, that is Make in India concept, we can develop the wind turbine in indigenously, and the operation cost can be reduced. I mean, the or initial cost can be reduced. So, for example, now I think recently Chandrayana, you may be knowing, maybe when compared to NASA activity, NASA moon exploration, the Chandrayana spent maybe some 20 to 30% amount. That's all with compared to NASA. What I want to say is, if we use our own knowledge, our own technology, maybe the cost of the product will reduce. Okay, the initial cost. Even when we install the solar panels or wind turbines, but presently we are importing the parts of the devices, that is turbines, the wind turbines, or including PV panels, and because of importing, the uh, cost of per unit energy will be increases. Okay. So limitation of the wind machines, already wherever wind energy is there, that is more than 6 meter per second or something. So the high velocity should be there so that we can convert wind energy into that. So it is based on the place. Electricity from wind machines must have backup supply from another source. Even I think, I mean, if you visit wind turbine power plants, you can observe there will be generator for rotating the blade. And even because we cannot expect the wind velocity will be constant throughout 24 hours or throughout the day. So the wind velocity fluctuates. Sometimes it will be stagnant, and for that we need another source. When we use another source, again it depending on the fossil fuels. Electricity produced by wind power plant fluctuates. That is based on the velocity of the wind. Okay, and noise made by the rotating wind machines blades. I think you might have read it in articles. So when we install the wind machine blades, I mean wind turbines, it makes a lot of noise. Even you can hear, I mean 2-3 kilometer away. Okay. Even for example, you take a fan. When fan is rotating, you can observe some sound. Okay, so like this, but wind turbine makes more noise. So, but there is a scope for research. We can reduce the noise, and we can improve the electricity, production. Next comes to solar energy. So, solar energy, you can observe nowadays, maybe uh, since from 10 to 20 years, the installation of solar energy power plants, or the power plant capacity is increased. uh, maybe I mean, from the data 2014 to 2019, you can observe the production, that is 2.6 gigawatts to 30 gigawatts. That is that much power plant, solar panels are installed, and electric energy is produced from the solar. So that is already I pointed out, the solar panels are placed. That is, modules are placed in the wasteland or the tall buildings where the terrace is not used for some other purpose. We can install the PV models and we can produce electricity. That is, locally we can produce and we can connect it to the grid, the main grid. Technology needs get further improved. As I said, there is a scope for improvement if you take any technology. A lot of research is happening towards the PV modules, including integration of PV modules to the main grid. Like this, a lot of work is going on related to this. So already I pointed out Make in India concept. We can develop the solar panels in India. We can reduce the initial cost of the system. This information you can see, uh, that is from the solar. It is coming per year. That is 5,000 trillion kilowatt hour per year radiation is coming from the solar, sun, and it can be converted. Even if you convert 1%, it become a huge. Okay. A density of radiation equal to 4 to 7 kilowatt per hour square meter per day. So these are all technical data. Present scenario, around, as I already pointed out, 30 gigawatts is installed. So the government of India is targeting 100 gigawatt capacity solar energy by 2022. I think recently, maybe some 1.5 months back or 2 months back, in Uttar Pradesh, they've installed a solar energy park, and that is the Asia's largest solar energy park. In maybe second, Rajasthan or uh, Moodabidri power plants will come. So this is the information regarding the solar power plants. So you can observe Rajasthan, including the Pavagada, that is Moodabidri district, and some other places that is less. Okay, and the recent one I have not included. The in UP they have installed. Challenges, manufacturing is one. Material is a second one. That is manufacturing means we need some material. Again, we are depending on the China or other countries. So the manufacturing cost will go high. The basic parts are taken from other countries that we have to avoid. We have to develop in our own country. Land area limitation due to population. So even nowadays we cannot say it's a bare land, it's not useful, but because of population and people are moving from rural area to the urban area. And next method of energy is the uh, waste energy. That is, we have to convert uh, the urban waste into the useful energy. So I think in Mangalore also they've installed installed some power plant, that is where we can convert urban waste into the electricity. So it is happening in small towns. Okay, and but as I said, if you install such power plants, the initial cost is very high. So that is a worry. Waste to energy potential as estimated by government will be this much. That is 556 megawatts by 2050. 186 that is waste to energy projects for generation of biogas till this one. The government of India is funding for technology. That is, if you convert from waste to energy, maybe Ministry of Renewable Energy is giving funding. So from waste, the urban waste, we can convert into methane gas or to the electricity. That is a thing. So earlier I mentioned when the power plants are away from the urban area, so the transmission losses will take place. So the transmission will be there. So nearly 24% or 20 to 24%. So how to avoid this one? So we can, because some power plants we cannot install nearer to the uh, urban areas, because for example if you take a coal based thermal power plant, then the emissions will come. Ash problem, ash disposal is also another problem. So when emission comes, then definitely it affect on the uh, humans, that are I mean people who are living in the urban area. So that is one problem. So we have to identify the renewable energy, because from the renewable energy, whether you solar or this one, then we can avoid emissions, carbon dioxide emissions. The purpose essential to take care of aggregate technical and commercial losses, renewable energy integration, peak load management, power quality improvement, creation of microgrid and distribution generation. So for example, so you assume that nuclear power plants are there in the Kaiga, and power is supplied to the Bangalore. So nearly 400 kilometers, the transmission losses will be there. Instead of that, we can install the solar energy power plants or some other renewable energy power plants nearer to the Bangalore, where the distance are less. So we can avoid transmission loss. The second thing is already the peak load management, because early morning, maybe 7 to 9, people are using electricity in a bigger way, and even nights, maybe after 6 to 9 or 6 to 10, there will be peak load, that is more electricity consumption. So during that time, how to manage this? Because we cannot extract more power from the main source. So in such cases, we can introduce some microgrids or micro electricity generation systems, including solar energy or wind energy, or including hydrogen fuel based ice engines or something. We can generate the electricity, we can connect it to the main grid, and we can manage the peak load. Okay, and we can improve the quality of the power also by introducing the new technologies. Next thing is, as I said, when we take the sustainable energy, so uh, it, that is whatever system we take, including solar PV panels, it should give a very good performance. Okay, so whatever building we develop, or whatever this one, we have to see that it should, I mean, high performance devices. Okay, efficient appliances, including, I mean, nowadays you may be knowing, when we buy TV or refrigerator, it is coming with 4-star or 5-star. That is energy efficient devices. If you go for more stars, that is 5 or 6, then it is more efficient compared to 1-star. So lighting, I mean, already I told you, instead of CFL, we can go for LED bulbs or LED lights so that the fuel consumption, electricity consumption can be reduced. Efficient heating, ventilation, and air conditioning system. As I said, when we are constructing a building, we have to see the proper ventilation and natural air circulation so that usage of air conditioning system can be avoided. Or even if we use, we have to use minimum. Building automation and control system. So I don't know how many of you have observed nowadays. If you want to get into room, getting to house, all remote control, or even just you go and stand in front of the door, the sensors will identify you, and automatically door will be open. So, including the operation of ovens or refrigerator or heater or air conditioning system can be done online now. Okay, that is a control system can be introduced by using the IoT system, okay, Internet of Things. Use of already I told you, daylighting, heat pumps. That is wherever the electric devices, appliances are we are using, we should give high performance. So, system efficiency improvement, passive house standards, uh, net zero and energy plus energy buildings, integrated design process, urban planning, direct heating and cooling, commissioning, advanced building control system, high efficiency distributed energy system, like that. Many things. And there is, we have to say that whatever sustainable energy we identify, we should give high performance or high efficiency. Okay. If you want to collect the data, whether it related to the number of vehicles or traffic control or even safety of the house or even land records and etc. We can get easily by using the internet and ICT, that is internet and communication system. Okay. So once we use the data, then there is a scope for improvement where we are lacking, where it will be shortage or excess. We can manage. Okay, but only thing is the collection of data is very important thing nowadays. For example, even every day the COVID number shown and based on the internet, because the most of the hospital, all the hospital, that is a number of patients admitted to the hospital through online data will be shared, and within a fraction of a minute, maybe area wise or state wise, the number is shown. That is because of internet connectivity. Another application would be traffic management. Maybe nowadays you may be seen in traffic signals, they are placing the cameras. If somebody violates the rules, the police sitting in the police station, he can, he will capture the it's on capture, and he will send the fine document to his place, maybe through online or through the this one. That is an initial step. Maybe in future, including our driving license, the emission of the vehicle, emission certificate, whether insurance are made or not. Those things we can see online itself. We don't have to carry the hard copies. It connects the with the consumption unit, that is including electricity, provides control over the management. If you use Internet of Things, good software, we can extract any data and we can analyze. Industry and agriculture, so that is for carbon dioxide, greenhouse gases emissions from the industry and agriculture waste. You can observe the data. Okay. And the total energy consumption will be around 45 for the industry already we have seen, and nearly 17% of energy goes to the agriculture. Okay? That is for operation of the pumps, okay, the generators. Energy efficiency in the industry agriculture is sustainable, 27 and 33%. And the last thing is, I think you may be aware of nuclear reactor in India, and the VR, that is India is expert in thorium nuclear reactor technology, and they have developed a reactor. Maybe it will be operation after 2025, and once it comes, maybe the energy, I mean, conversion from nuclear energy into electric energy will increase. Okay, so maybe if this technology comes, it will be. I mean, uh, we can reduce the importing of fossil fuels. Okay, these are the methods of sustainable energy with respect to the solar, I mean, smart cities. Even many things are there, but only thing is uh, the investment cost we have to see. Whether, for example, you take here, I mean, Mangalore, the Dakshina Kannada or Udupi, that is a coastal area, we can convert wave energy into electricity. But only thing is, when we convert wave energy into electricity, again, how much, I mean, investment cost is also very important thing. And the next thing is the maintenance, investment and maintenance cost. So we have to see that the sustainable energy, so that the smart city will sustain. And So when we introduce all that is when sustainable energy or whatever, the proper regulation should be there. That is, the proper rules and regulations should be there. So in India, till now, I mean, we are working towards the uh, developing the rules and regulations. Maybe it will come within 2 3 years. We can expect, because already they have started investing the money. Maybe the private partners are also involved. Maybe in future we can make more effective. So this is my thought. If you have any queries related to the my presentation, uh, please. And these are the references. And if you want more information, you can log into this. I mean, many reports are available. Just you can see. Thank you.
Thank you for the information, Professor. There are two questions posted on the chat window.
Yeah.
So the head of the Department of Mechanical Engineering here at MIT has posted, please mention the safety measures to be taken while using hydrogen engine.
Yeah. Say. Assume, I mean, you go back to 30 years or 40 years back, when LPG was introduced, people were fear. I mean, people are not ready to use LPG gas as a fuel. Some explosion, explosion or some burning, something happened that time. But when people started using LPG gas, nowadays, even if you visit a village, you can find LPG burners or LPG gas utilization. The similar way, hydrogen at presently, it is a maybe because the people, I mean, common people are not using as a fuel, and because of this, people are having a fear on the hydrogen gas. Once we introduce safety methods, for example, now many sensors are available. Even small percentage of hydrogen leaks, we can identify immediately. We can switch off the. I mean, we can close the valve. That is one method. And with respect to the hydrogen fueled IC engine, we are using flame arrestor. Okay, the flame arrestor means, for example, I mean, if flame is developed nearer to the inlet valve and flame is moving towards the cylinder, if you place the flame arrestor, the flame will be stopped in the flame arrestor. That is, the flame friend won't reach up to the cylinder. Okay, that is, the flame arrestors are used. and the sensors are used so that hydrogen can be used as a fuel, and if you use hydrogen compared to LPG gas or compared to petrol, it is safe. But only thing is, in India, it is not identified. I mean, recently it is done, and safety codes also approved. Yeah.
Sure, sir. The next question is from D. Devar Siddhappa, who asks, what about the feasibility of producing electricity using carbon fiber?
I didn't get you. Common?
What about the feasibility of producing electricity using carbon fiber? He asks.
No, that's why when we use carbon fiber, again, whenever carbon is involved, carbon dioxide will come. It affects on the emission, greenhouse gas. So we have to see that uh, we have to convert carbon into carbon dioxide, and we have to go for carbon, I mean, underground. We have to convert carbon to fuel or carbon to methane gas. I mean, from other, I mean, methane or syngas.
Okay, sir. So there is another question from the head of mechanical department. Can you please highlight on carbon capturing?
The technology in India is new, and many are working. I mean, they are proposing ideas, but it's not implemented uh, anywhere. Okay, still they are working, and frankly, if I say I'm not working related to that, these all methods it can be implemented in smart cities. Okay, but the materials, I mean, maybe this national laboratory and material, somebody, they're working related to this, but nobody has come up with proper technology. Still, it is under laboratory condition.
Okay, sir. Any information regarding the materials that could be used for carbon dioxide capturing?
No, at presently,
Okay,
I don't
okay,
have any information. I have not gone in depth.
sure, sir. Another question from the head of mechanical department. How sustainable energy integration of smart cities can empower Atmanirbhar Bharat concept?
See, with respect to solar energy, I told you, now the PV panels are taken from the maybe China or through Europe countries. Okay, so instead of importing the panels, if we start developing our own, the production cost or the final cost will reduce. And not only that, you are generating the employment. Okay, well, if the employment is generated, then definitely the country will grow, and even the excess production we can export to other countries. That is objective of Atmanirbhar project. I mean,
Okay, sir.
indigenously we have to produce the product. We should not depend on the other countries, including the fuel importing.
Okay, sir. I think we do not have any more questions from the participants. So, on behalf of Mechanical Engineering Department at Mangalore Institute of Technology and Engineering, I thank Professor G.N. Kumar for delivering the talk on sustainable energy integration in smart cities. And also, I thank him for highlighting the various points which he had mentioned during his lecture, especially on the utilization of ash in construction and also making judicious use of construction material and to identify local energy sources, which is very, very important in the present energy scenario what we in our country have experienced or are experiencing. And also I thank him for providing information regarding the places in India where wind energy is in abundance and the implementation of more eco-friendly fuels over in Pavagada and many other places. So I thank Professor G.N. Kumar for taking out his taking out time and delivering this talk on sustainable energy integration in smart cities. I also thank All India AICTE New Delhi for sponsoring this FDP. Thank you, sir.
Uh, so at the end, I would like to thank Dr. Rashekar for giving me opportunity to share my knowledge on this field, and also I thank MIT for giving opportunity. So finally, I thank Vignesh for introducing me and for concluding remarks. Thank you, one and all. And even participant, I don't know how much you have understood, but what I'm requesting, you take it as a basic step. And if you want more information, please refer the references. You'll get a lot of information because, as I said, this technology is not new, or this idea is not new to the world. It's already implemented in European and the American countries. So a lot of information is available. Please go through and make utilize of this. Thank you, one and all.
Thank you, sir.
Okay.
So with that, we come to the end of day 2 of the FDP program. Thank you all.
Thank you. Bye.